All right. So just to run through the question, um, write a function to find the longest common prefix amongst an array of strings. If is no common prefix, return an empty string. And then your first example is strings is an array having flower, flow, and height, and the output is FL. And then for this other example, it's dog, race car, and car, and it's an empty string because there's no common prefix. Okay, so I think just looking at um, this array, we obviously need to hold maybe the shared portions on a maybe a stack or maybe a string. And looking at, I mean, just to clarify, is there any specific, um, I guess, constraints in terms of like time, complexity, or anything like that, or could we just brute force this first?
No, you can just go ahead and use a brute force solution.
Okay.
Really fine.
All right. So let me just understand kind of what I would have to look for. Obviously, we see that there's FL in each of the words in example one. So, given that, I think we would have to start pushing the shared values or the shared characters onto like a stack or some sort of data type. So, just to understand. So FL, FL, FL. Um, you know what? Actually, I think I would probably use a set actually and see if there are any duplicate characters. So maybe if I were to have, for example, this set, the initial set having, FLOWER, and then, I obviously check if, the current character we're looking at is in set, then, we could do obviously maybe string dot append that char. Does that sound reasonable to you, or like is that anything
Definitely a
that
solution. Yeah, yeah. That's definitely a solution there. So
okay.
I follow.
And then the only input is a string, correct?
Yeah, so for the if there if it's not a common sub
We just
common
return an empty
prefix,
string.
just return empty string.
Okay. All right.
Mhm.
So I'll just create a function, common prefix, um, and then obviously we need to return string. Well, I need to put a parameter. We'll just leave it like that. All right. Let's see. Just put, uh, oops, sorry. All right. All right. So this is the function. Now, obviously, like I said, I'd have to create a set. So I'll just go ahead and do maybe. Okay. And I guess now what I'd want to do is um, look through because the way I'm looking at it or perceiving this is that each of them need to have the same prefix. So I can really just add the first index string to the set, and then I can check the other two if there is a common prefix.
Okay.
So, and then just wondering, so I guess just a clarifying question. So for example, if there was flower flow and then maybe there was a difference in flight to where it didn't have an FL, this would be an
Mhm.
empty string, correct?
Correct. Yeah.
Okay. Um, So I guess now we need to keep in mind what we need to look for then. Um, I guess I would start by hmm, FL, FL, FL. Right. So if I were to continually add per loop or per iteration characters and then each time check if there is a duplicate, this would seem like it would be requiring a nested for loop because I need to not only check each index, I need to check each character.
Which is fine.
So,
You can do that.
okay,
Just do use a you don't have to worry about complexity. Just a solution is
right.
fine.
Okay. So I guess I'll do just for I in range of the length of strings, and then oops, where to put it? Okay, and then um, from here, I would now from here we can also put our second for loop, and I think from here I'll start from uh, I and then the length of strings since I don't want to also look over I and potentially have some issues with returning true even though I'm looking at the same text. So um well I'm not returning true, sorry, returning a string. So I guess just to add on to my example here, I would then return the clean string. Okay, so this also lets me know that I need to also have a string. So because we're returning one, so let's just put prefix, and this is gonna be our string. Put it empty right now, and then um, I think now we will go from each string and start to add them. So actually, I'm gonna change this logic. So I'll put for word in strings, and then oops, and then for character in word. I
Yeah,
think
that
that's
looks
better.
great. Yeah.
Um, so now that we're in one word, now we're in a character. I will then um, check initially. So if char in char set, I'll do prefix and wait, no, prefix. Sorry. Prefix add, we'll just add char. So this is gonna add the character to our prefix, which is um, our string that's gonna have the common prefix. So from here, I will then, after each iteration, we will add to our char set. So um, I'll go ahead and do um, the char. So this will then add our character. And then I guess over here we'll return prefix. So I guess let me just run through this code and see if it's correct. Um, we go through each word and for each character in the word, if the character is in our character set, we will add that character to a string and then oops. Yeah. So we will add that character to a string and then um, we will return that prefix. So I guess I'll just write a little
Well,
test case.
can I ask a question? Why are you creating so on the prefix line number 37 for
Yeah.
each word you're just adding the character into a variable called prefix, but won't that just give you every single character that's in the input strings into just one variable? Like what's the point of
Could
adding?
you repeat that question? I'm sorry, I couldn't hear it.
Yeah, so line 37, right?
Yeah.
Essentially what that's doing is concatenating every letter that you come across into the variable prefix, right? So just imagine that this for loop is running. Just go ahead and you can run the code. It'll tell you what prefix is. But I'd imagine prefix is like one long string.
Hmm.
But that's basically my question is why do you need to concatenate every single character into one long string?
Um, I guess, obviously since we're returning a string, um, and I'm checking if that one character we're looking at is in a character set. So then I'm adding the character. Okay, I understand. So this is gonna create a bunch of issues with
Why,
how this will be
why don't
stored.
you why don't you do this? Run the code,
Sure.
print out what its output is.
I'm pretty sure I kind of have an idea what the output is, but I will run it anyways.
What do you think prefix is going to be?
I think it's gonna be a bunch of the same letters
But in what format? Like how do you think it's going to look?
in a long string.
Yeah,
Okay,
great.
so common prefix and then strings. All right, let's see. Yeah. So let me just understand this. So um, obviously we add at the end of each iteration. Um, now, as far as we need to look through this, so flow FL, um, we go from word, character, and we see that if we go from if we see that it is in the set, we're adding one character, so then it um adds F. Could I if you don't mind, put a print here to
Yeah, of course.
understand what we're looking at? Okay, I was right. So yeah, we go from FLOWFL. So the issue is that we get flow. So our initial part, we get flow. And obviously we only put FL from there. So I guess it's just the initial portion of this string that we have to, or the first index of the string that we have to keep in mind. So I think we could probably save a little bit of overhead here if we just went ahead and um, added the first portion of strings um to our set. Ooh, hold on. This should be in a list just to understand. Okay. Um, so I will go ahead and add to char set and put the first index. I think that would be the best way to go about it. So I would then put list index 0. And if this were to go, so obviously we now have flower. So if we then have flower, we go to check against the next characters, and it would be
So
FL,
you can
FL,
you can
FL.
you I see what you're doing. You're setting the prefix already in the char set, which is wonderful. That's great. That's perfect. So just adjust your for loop. Where do you want to start the index from?
We'd probably want to start the index past the first portion then.
Back. Perfect. Yep, you got it.
So then, I guess
If you
just
do a
edit the
range,
logic. Yeah, exactly. So for I in range and then length of, actually start at,
one,
and then length of strings. So then we need to switch up this logic a little bit and we'll go, um, actually, so for I in range, basically we're in each index. So then we can do for, um,
yeah.
and so now we are in each character in an index. So then we compare our first part to the rest of the characters in the character set, and then we return that. So let me comment this out, and I think this should be okay.
Very, very nice. Okay, can you try the other test case? Up,
Sure.
up.
Um, just copy that over. Oops. Okay. Let's go ahead and try that. Ooh. Okay. Okay. Yeah, I understand. So the first part does not have the okay, yeah. So obviously we check dog or we put dog in there and then we look at our race car and we see that we have car here and then car in the next one, but we don't
Have you heard
have
have you heard of the, sorry to interject your thinking. Have you heard of the term short circuit?
um yeah, and could you in terms of what?
A short circuit is anything that abruptly stops the procedure from continuing forward.
Right.
And in terms of programming, where do you think you can add a short circuit here in order to stop the iteration because of something, a condition that you found?
Okay. So I guess we can compare if the zero index does not line up with strings of I, or if there is nothing remotely similar about dog to race car or even car, we can just cut there. Um,
Where do you want to short circuit this? Like, do you really need to evaluate the last string, uh, even though that the dog is basically not a common prefix with
right.
race? Exactly. So
So I think probably before I even start adding things, when I'm in this char and strings, I can um, start to compare from dog and race car and just return an empty string from there. So I think obviously we are in our index. We already have dog in our set. So I would go ahead and say if hmm, I guess just thinking about this. So obviously we go from character and strings. That's where we are. We are currently at R, and from there we go RACE, CAR. Um, we could just see that we have nothing in common between dog and race car by putting a condition before we even start adding. So
why
obviously we
why do you want to put the condition before, and what benefit would that do if you did it before versus after?
I say before because we are adding like car and car again for basically no reason if that is not what our prefix is. I think
That
actually
that is correct, but what I'm saying is that let's just say that you have dog in the car set, right?
Yeah.
And you're evaluating race car. So and then race car goes through your loop and it's checking if the car is in car set and then it's adding that to the prefix. So what can you determine if if you iterate through the for loop, right? You're iterating and you're on race car. Where in this process can you determine that, hey, these two don't have anything in common, so I can just break?
Right. So I think I will then if the character is in care set, I think after I add I can check or maybe at the end I can compare the
Okay.
I can start to compare the first index to what we have in our set. So I think
Well, look at what you're doing there in the car set, uh, in the condition on 38. What what are you doing there?
mm, right.
Look at
Um,
that specific line of code. Can you make a determination that there's no there's no common prefix between these two things?
right.
What tells you that? What's the most identifying thing there?
Just obviously we go through this condition for dog and race car. I don't think it even goes through this. So maybe um if we put I think then from there we would add an else clause and um potentially check. So we have dog and then we have
What
race car.
one more thing I want to interject there. If it never enters that condition, what can we what truths can we hold about that about what's going on in that condition?
If it never enters this conditional, then it's not a common prefix then.
Well, what determines that?
Um, Obviously our set, so dog and the characters in race car, they have nothing in common between each other.
Okay, but your condition is clearly guarding against doing something. What is determining that there is no common prefix?
Could you repeat that question? I'm sorry.
So your condition there is guarding against something, right?
Yeah.
What is it guarding against, and what is determining whether it's a prefix or not?
So this conditional is guarding against the event of there not being a common prefix. So obviously our set can have no duplicates. So
Right.
um,
But what action are you taking to basically uh say that there's no common prefix? You're doing something in that condition, right?
yeah.
So what is that?
So we're basically saying if the character is not even existing in our, or if the character is in our character set, then it's a duplicate. So then we add that duplicate over to character. So I think then, if that's not the case and the characters is not in, are not in character set, then we could,
If it's not in the character set, what assumption can you make?
if it's not in the character set, then we can assume that character specifically is not at
But
all common to
how do you do
dog.
it? How have you done? How have you laid out in your program that is in fact true?
Right. So, we need to add validation then to,
No. You have it there. You're looking at it. You
right.
have to just look deeper into your code.
So,
What makes you think there's a prefix or
so character and character set, prefix plus equal char. Right. So I think then, we then add that character to the prefix. That's why we have
okay?
car and car.
What happens if there's nothing in common? What happens there?
We just break and we add to,
No, I'm not talking about the break. I'm talking about if you're iterating through right now, if you're iterating every character and in the string that you're currently uh in the list of strings that you're currently iterating through, if you don't find anything in the car set that's relatable back to the original prefix that you set, or the original thing in the car set, what determination can you make? You've you've
So,
you've clearly written code that does it for you,
right.
that's keeping track of whether there's a longest common substring or not. But I just want to point to you so you can see that.
So, obviously the character and char set print. Okay. Um, so then we go prefix character. Okay. So I guess we should just look inside this portion of characters and char set. We can see um if that character is at all similar to our initial part, then
A
we
good
can assume that it is.
what happens if it has things in common versus things not in common? What do you do specifically that tells you that?
Right. So if it is uncommon, we add it to our prefix. But if it's not, we should
Okay.
just
Ex exactly.
return an empty string.
Exactly. So
Okay.
what determination can you make if it's a common prefix or not?
So we could see that uh, if dog is having at all any similarities with R, then if dog has no character similar in race car, then we can just return an empty string and cut it there.
But what makes you determine that?
What makes me determine that?
Yeah. What are you doing in your code that is basically saying, hey, there is a common prefix or there's not a common prefix? Look at
Right.
line 41.
Right. So we add the character to our prefix, but
Right.
I
So
think
what
then we would have to compare our prefix to our initial portion.
well, not necessarily, right? Because what are you doing that tells you whether there is a common prefix and there isn't?
The set.
No, but what are you doing specifically on line 41?
Well,
I
in
mean,
line
that is
41,
true.
we're adding the character to our string
Exactly. So what determination can you make?
to identify if it is a prefix.
Yes.
So I guess then when we add to the character, we need to also make sure that the text we're adding lines up with what we have in our current set.
Okay.
So character and character set, prefix character. Do you mind if I print prefix here to understand
Yeah, of course.
what prefix would look like?
You might want to even add in the string
Add in, oh, right, yeah. So,
string it's evaluating. Just do strs of I. You can put it right there in the print if you want within the first the yeah.
okay, so we're in race car. Obviously, we go C, CA, CAR, 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 CAR.
But notice it did something, right?
It basically duplicated it. And so not only do we have issues with duplication, we also need to um, check if that lines up with the first portion. So initials dog, it doesn't go through here for at all in any of the characters in dog. So we go through race car, it's C, CA, CAR, and then we go to car and it's CARC, CARCA, CARCAR, and then we end with car. Okay. Um,
Just above
so
it, can you do me one more favor, which may give you a big clue? Just above the if car and car set, can you also print out the string you're evaluating? Apologies, all on between line 35 and 36.
oh, okay. So yeah, we go through race car and then we add everything in race car and then we add everything in car. So I guess I think I understand this. So every time we go through a word, we need to check initially before even going through second loop. Um if that word even lines up with what we have in our set. So we could compare dog to race car using our set.
Okay.
So I think if there is nothing even in common with dog and race car, then we can just return a empty string. So if um, um, would this work? So strings of I, not in care set. So that'll be race car if that's not. Hmm.
So what you're saying there is if string of I not so it looks like you want to do a substring match, right? Or wait, car set.
Because we already have dog in there, and I think we can check earlier if before even adding anything to our set, if we
Yes.
check that if the word is not even remotely similar.
Okay. Not in car set. I'm not okay. Give that a try.
But
I'm not sure if that'll
sure.
actually work or not, but worth a shot. Yeah, it just returned empty, which is right. Um, but go back to the original test case.
Right. Um, let me copy that over. Is that right? Okay. So yeah, this is checking the whole text for what that is. So this
If
could be
if you want to do a substring match, you can use dot find. Um,
so if we did dot find then strings of I, if we found we're looking for flow in what we have in our set. Would that also be an issue too? Because we would just return, you know, that we can't find it. We would return a false.
well, that's what you're determining is let's see. So if you run through this and you use a dot find, which is basically going to do a substring match, and what you're saying is that um, you're going to use what's in the car set, which currently contains one one element that's dog. And then if it's not there, return. Which I think that should work. I don't see a problem. So if it's the other way around with flower flow. So, but you can determine like, do you want to maybe do some print cases here? Do you want to run through the code? Maybe it's better that you walk
I,
through some of this and see how that
right.
works.
I think actually, we could then instead, so after we add a word, we go through an iteration, for char and strings. We then, I guess, can I just run through my initial,
Mhm.
um, run through just to understand this a little more? So, right. So we put C, CAR, CAR, and then um, just to clean this up, we need to then check if we can then add our prefixers to handle the duplicate issue. Okay. That was just to clean up, and then now we need to check, obviously, it not being a prefix. So um, at the end, I will then check um, our. I'll just do um, if strings of zero is, or actually, hmm. So I guess the issue that or what I was thinking was I wanted to check if our initial is at all equal to or at all, in our current set, our char set, which it would be, which is the issue. But also another issue is if I check a whole string against a portion of it, I don't want there to be issues with the logic.
Hmm.
So if char not prefix, we handled the duplicate issue. Now we need to handle the validation. So um, we need to then compare our. So for in range, obviously we go from word to word and then character to character. Um, just give me if you don't mind, just a quick moment to understand this and
Yeah,
what
go
I
ahead.
need to do. So if we go from our, obviously not, it's not in the prefix, so we add it. Then we start with race car. Now, from what I know so far, we need to look at a character level then, correct for validation, because if we look at string for string, it's not going to always be correct. We need to look at the common prefix.
Uh, can you expand on that? Um,
Yeah, so if we were to, look at dog and race car, obviously they are not remotely similar, but if we had like something like flower and flow, we saw that in that previous attempt, it would return empty because flower and flow are not
can you
exactly.
can you throw some examples up here? I know like speaking through stuff is great, but I usually like just
Sure. So obviously we have flower in our current our char set,
okay.
and then we're obviously if we were to check on a string level, we would have, just in terms of logic. So if flower or if flow is in char set, obviously this one is to an extent true. But then if we do if flight in char set, this would then be a potential error since flight only shares two letters, our char set.
Okay.
And then we can't just compare the first to the second or third because each one of them can be different. So like dog, what if dog was on the end? Then how are we going to check? If because we could have car and then we compare it to dog. So it definitely has to be inside. The validation needs to definitely be inside here.
Mm-hmm. Okay.
Um, and I think the way I'll do that is by checking if, oops, sorry. So we have prefix of char, so we add the um, char there. I think before I even consider adding a a value to our char set, we can just compare then. Um, I think we do prefix. I think then we can start to find if there is a similarity like between C and dog. If there isn't, then we already know that's false.
Okay.
So I think we can, before we start adding things to our char set, we can start to, um, so prefix dot find char, and then, um, what does find return? Returns an index. So, would this, in the case of it not being an existing, it would, okay, it would return none. Um, then return. I think this would work.
Hmm. Okay, so you said if it's in the if a character is in the car set, which just means if you find a character that already exists in the car set, and your condition on 48 says if it's not in the prefix, then I'm going to add it in the prefix. But if it's not found in the prefix, then you evaluate the character by doing a substring match on the current character that you didn't find in the car set inside of the prefix.
Okay, I can see this is a little confusing now that I look at it.
Yeah, there's a nice
So,
cleanup here. Uh,
right. So obviously, we print prefix and strings of I. If prefix dot find char is equal to none. So yeah, there's an issue here. Um, obviously we're adding from there. So that's the issue. I think we're not going to check the prefix because we just added to the prefix. Um, so I think before we even think about adding a character, well, actually it would be in a character, so this is also contradictory. Um, so
you're looking for a character inside of another set of characters, but what determination are you really trying to make? I mean, find can find I mean, if we look at what find actually does, it just does a substring match. So you could actually compare verbatim two strings as a whole and use find to determine whether they have a substring within them. So like for example, if you said like let's see. So if you said like car set dot find, I don't even know if that's right. I think it's like this. Maybe could be wrong about that, but and let's just imagine like we say let's just find flow, right? We'll use the first example, right? And let's just say car set um equals this, just flower in there, right? So if you use find and you're saying, hey, I want to see if there's a substring flow within flower, this is going to return true. And what does that tell us? That means that yes, flow is definitely a substring of flower for sure. You can see that, right?
right.
So the first four characters are both substrings. So, but the most important thing here is that you can compare just a whole string. You don't have to do this, right? Um, where it's just like comparing one character to one character or whatever.
Right, because it does like a whole
Yeah,
substring search.
yeah, exactly. So, yeah, hope that
So
hope,
we could just validate here then, correct? Because we're looking at string for string at this point.
yeah, yeah. You
So
don't
I
do
guess I'll
that.
just retract this statement here. and I guess paste it here. So then we currently have um, okay, so we'll do char set and then we'll do um I don't think there is a find part in char set.
Yeah, you're right. Apologies. That's a string function. So you could
I
take,
mean, they do have a subset built in function, but a that's not really a
hmm,
direct approach of solving it because I think that one is I believe order n
you could just use strings.
rather than a set.
Yeah, you could just compare whatever.
Right. So I guess we could just do strings of zero.
Hmm. Yep.
Well, actually, there is no method for, yeah, there is method.
Yeah,
So,
there is because it's a string,
right.
right?
Yeah. So, and then we can do, so if I is, equal to, then return. Then from
Yeah.
there, it's going to return a white space. Okay. Let me see how that would run. That is very strange.
Well, it th that's fine. It is supposed to return empty string, right?
Right.
You could remove the print if that's confusing you on the line
Oh,
50.
right. Right. Yeah.
Uh,
Line 50 right here.
you just comment it out in case you
Yep.
need.
All right, let's see how this would look then. We have car. Okay, so there's an issue here. I believe, well, like you said, it was a substring match. So what if at the end we could do the find then? Is that the better way of going about it?
I
Because,
think 55 you added previously. I'm not sure. Oh, okay, okay. I don't. Okay, so let's just see. Um,
so,
yeah, you maybe take away line 55. Yeah, take that line away.
but then what would that give us as far as, um,
And then now uncomment 58 and comment 59. Okay, yeah, there's definitely something still wrong here.
I think that portion where we add is, somewhat. Well, actually, you're correct. We wouldn't need that because we're already pushing one part of it over. Right. So, um, okay, I think that actually helped me clear up a lot of the confusion. Then if that's the case, we wouldn't even need to validate that early. We could just press the or check the current set against the current word. So I think over here, we could do and then maybe. Well, there's no fine for this. So I think from then we could just check if, dog is actually comparable to race car since we um, already have the characters that we could have in our set. And in order for this to be true, there needs to be at least some similarity between dog and car or dog and race car. So just to, I guess, run it, just to understand what. this would look like then. This would be car as the out. Okay, there's no car at the output. So car not in prefix, prefix is car. Okay, let me try the working case before I look at this again. Okay, returning empty here. So for I in range, car in string, if car in car set, um, if it's not in the prefix yet, we can add it to the prefix. So I guess the issue here is now we're not even returning anything, which is a major problem. Or actually, we're need to even print if we're going to the loop. Well, we should be, but okay. We are going to obviously we would be going in the loop, but I don't even think we're going in here anymore. But that should be correct because we have flower and that should have some similarities with flow. So for car and springs in range, and then for car and strings of I, if the character is in the character set where that would probably be the fix. Well, actually, we're not even entering this, so that's the issue. It wouldn't be that.
Yeah, but can you determine why you're not? What is it in car set?
We have flower in there, and
So it's flower in there. So if you're iterating through the characters in F flow, and the on line 45 it says, so let's just assume it's the first character F. If F is in the car set, what's in the car set? There is uh FLOWER, right?
right. So it matches the F to the
Hmm?
F in flower. Um, and then I guess we should then enter this, but uh, we're not, and instead we're not even entering our condition to even check if it already exists in our prefix.
Hmm. Can you want to print something before that line to make sure like the
Sure.
character that you're looking at and the car set are properly being evaluated in the condition? Hmm. Can you see a issue there?
So flow, and then we have flight. Let me see. So obviously we have F here, which is our character, and then inside the set we have flower. Um, I mean, I am struggling to understand like this should be syntactically correct, right? As far as, we obviously compare the current character to our our current set, and we have so if characters
If
in the
if
character set.
if you do this, what do you think it's going to evaluate to? So clearly,
False.
you can't do that. What is it about car set that you can't? The reason you can't do that?
Hmm. So we go from FLOW, FLOW, or FLIGHT, and then okay. So I think the issue with this is that we have to we have okay, I think I understand. So we have like a full string and we're comparing that one portion to that part. So I think the issue is could we um loop for our first edition of char set to only put characters because we currently have a full string. It should be F comma L comma O comma W comma E comma R, correct? Like char set should be looking like this. Is that correct?
Yeah, but yeah, yeah.
Okay.
Uh, I think that's okay, but why not just use a string? You can, I think you can,
Yeah, we could just go set a car string to equal to that, and then from there we would then get some trues. So now we enter the loop and we still don't have an output. So let me just run this one more time just to see what the full output was. So we're getting flow, which is strange. So that I guess that was the whole reason why I thought a set would be good to implement, just because we could um check for duplicates, and if there's a duplicate, we can go ahead
yeah.
and add it.
Go ahead and, yeah, I totally get it. Go ahead and revert it and go back to your car set data type. Um, let's fix it from there. Yeah.
Um, I don't know. I think I have a certain idea to implement. If we were to loop through our first part of car set and just have it be actual characters rather than a full string. Um, or I guess even before that, that was kind of why I think the whole reason why it worked was because we did car set plus equals to our character. So I think we don't even have to if we just leave it as empty and then go from the actual beginning, that would let us start to add. And I think if I guess let me just run through this and then um like the strings, then we would actually be able to oh wait, I did dot add. Then it would actually be a full character like that. So false, then we add F and false, and then we add L, and then from then on we start to add our parts.
Hmm.
So then from here we go from F, FL. Let me just take that out. It's confusing. So we go in, but it should not be flow, it should be FL. And I'm not sure what happened between this and the first iteration, but it did work initially.
There might be some indentation issue, as far as I can tell. I think there's something going on with how the indentation.
Oh, I think it was like this, if I was mistaken. Okay, this is an issue. No, in my initial run through, I had it like this, and it was not creating any problems until we started trying to debug for the second case. So this does give me flow, right? So I guess the issue with this is that let me just remove all this just so, okay, so we reach test for FL, FLOW, FLOW, and then that goes till flight.
What you're doing is correct. Um, but what it's doing is this. Um, so the car set has flower in it, right? So car set flower, right? And then it goes through your loop, and then for everything that's not in car set, it's gonna add um sorry, if for every character that's not in prefix, it'll add it there. So right, so that's why you get the FLOW. Uh, let's- So yeah, it'll only let's see. So for each character in the string, if character in car set, so F is definitely there. A character not in the prefix, so add it. So you get F, you're gonna get the L, you're gonna get the O, you're gonna get the W, and then now you're not gonna get the ER because they don't have common substrings there. Okay, so that figures out that case. So now you're in car set again. Car set still equals flower. We know that. I should say that this is for flow. So this is for flight. So car set is in flower. So now you're saying what's the common things here? So you get the F, you get the L, which is right, but then they don't have anything else in common. But you're not your prefix is still this. That's why you're getting return flow. So you've made a determination on this one that this is the only common prefix, but you didn't do anything to prefix itself to show that
Right.
it should be FL. So what in your code can you do to
Um, well, I'm not sure if
can you make changes to the prefix? How about that?
so if we were to go so prefix.
Can you edit prefix somehow and say, well, this isn't this so if you determine that F and L is the only common prefix between the previous two or the one that you're iterating to, then you need to make changes to prefix.
Right.
So how can you make prefix? What type of logic can you put in there to make prefix FL?
Um, well, I mean, if we look at our, we have FLOW. It's just a little weird for me considering the first time we actually did get FL, but I'm not sure, or actually, well, the thing that changed was that we had flower in there initially as compared to there being flow.
In the character set, you mean?
Yeah, in our character set we started out with flower and then we were able to end up with FL because we checked character per character and we saw that there was
Mm-hmm.
only FL amongst them all.
But if
So,
the issue came about when we tried to do something that wasn't within the common substrings, and then it didn't return correctly. So I think
right,
that's why we pivoted. We went a different route.
right.
I'm not sure I can't remember what the it looked basically like the what you wrote up here.
Yeah, it was just we put inside our set we put the first or zero index, which is flower, and then we checked them then.
But clearly what I can see what's happening here is that you're actually getting flow in the prefix.
Right.
But uh last uh on the last word inside of the strings array, flight, there's nothing in there that actually changes the prefix to say that, hey, the common prefix is not inclusive of, or is only now inclusive of F and L. So there needs to be something here that says, um, I need to edit the prefix because I only found two letters that are common between flower and flight.
Right. Um,
You
so,
you've already when you've already ran through flow and inside of the current prefix equals flow, that's completely fine. You've already determined what the common prefix of that one is. So now when you compare flower and flight, you can really you can the thing that you can take away from this is that okay, there's only F and L that has a commonality between those two words. But you can also assume that what you have in the prefix, you can assume that flow is also part, you know, if you use F and L, then you can determine that all three of those words have that common prefix because you've already iterated through flow and you determined that F and L is already a common thing between flower and flow. So all you would have to do is edit prefix to match all three of the all three of the common letters that are in these strings.
right. Um, well, I mean, considering that, I guess I'm over time now, is there any changes you would make to, I guess, my program in terms of solving that root issue of um, the second case?
Yeah. So do you want me to just give you basically the way that I would solve this?
Or I guess maybe like the rundown on like the yeah, sure. Why not?
So okay, but let's see if we can fix your the way that you were doing it. So here you said you were adding to the prefix, which is fine. There's nothing wrong with that. But the determination you want to make here is so how do you go backwards on the prefix, right? Um, so let's see, what are the things that tell us that there's some commonality between flow and flower? I'm sorry, flower and flight. So you have this car set thing that you add car here, and let's see here. So it's not in the prefix, and add the character to the prefix. Okay. Can we do something conversely, where we say else uh, to decrement that from the
Hmm. Right.
right? So, what can you think of a way to just say, hey, what's the converse of this?
Well, we could just so I guess if it's not in the prefix to exist with, then um we're incrementing, and then um I guess this is for a duplicate checking then. I mean just to understand this K initial, it is for duplicate checking.
Yeah, yeah. This is the dupe checking here. So if the character is not in the prefix, right? Um, okay, so what if we did this? Okay, let's make the prefix strings of zero.
Hmm. So then from there you could just remove the
Yep. So let's do that. Um, I get that you did the car set thing and you're just trying to compare the characters, so I'll just comment that out. Just leave that here. Okay. So this is okay, and this is all the character type logic. So, but what if we just basically did this and said, uh, yes, strings of I. So we want to do the substring match again on the prefix. So that is going to be find the prefix, right? So all I'm saying here is this is that when we're iterating uh, through the list of strings, I just want to determine if there's a common prefix there and then take some action after that, right? So if I do find a common prefix, that's going to be true. Um, which at that point, then I will want to, so let's see. Okay, yes. So I want to find if it's true. So if it's not equal to zero, meaning if it's not equal to false, what I want to do here is I want to work backwards on the prefix. So if the prefix right now is set to this, flower, what I want to do is I want to work backwards. And what that means is if the next word is flow, I want to somehow iterate backwards where I'm saying, okay, well, there is no R, so I'm going to look at this. So I'm going to subtract one character from the prefix. There is no E, so I'm going to extract another character. Now I have flow, and that's going to be my prefix now.
Right.
Prefix equals flow, right? On the next one, which is going to be flight, just do the same thing, right? So right now, I'm going to subtract anything that's not in there. But so far, W is not in flight, so I go to the next one. T is not in flow, so I go to the next one. H is not in flow, I go to the next one. G is not, uh, sorry, I looked at this back the other way. So W is not in flight. O is not in flight, but FL is.
Oh, okay.
So
So
now
it's
pre.
just right. So slowly removing the difference.
Yeah, so how do we do that, right? So let's just keep setting the prefix to the prefix, keep subtracting the prefix basically.
Right.
What I'm keep removing things off the end. So how can I do that? Um,
You can do well, you can do -1 to get the end of it, right? If you want to slice that
yeah,
apart.
yeah,
You just do
exactly.
prefix of -1.
Okay, so where does that get us? Let's see. Let me run that. Okay, so that works. Uh, do you see why? Do you see what's going on there?
Yeah, so you take obviously I guess the way I went about it was much different. Um I was looking for or using a data type that was gonna obviously not allow duplicates, so I went like that. And the checking of inside a set is pretty straightforward, so I thought it would be an easier approach. But I think this makes a lot more sense since it is much more simpler as well. Um, you just put the initial word in, and obviously there has to be some similarity between all the other parts. So you just take off whatever's different by one until you eventually get your portion.
Well, we're missing something here, right? Because this will keep checking for it'll so it's a while loop, right?
Yeah.
when does it not evaluate this? It only doesn't evaluate that when this condition is false.
Right.
What does that really mean? Well, we're gonna keep cutting the prefix until it turns to false. And if you look at here, it says find prefix in so it does a substring, right? It looks at the prefix, like whatever the prefix that we set. So currently the prefix is flower, right? And then
Yeah.
the next one is flow. So the find will just say, hey, is flow a substring? I'm sorry, is flower a substring of flow? Uh, not equal to false. True, it is. Oh, wait, is that right? Flower is not equal to zero, which is false. So it's true. And then it'll keep uh basically throwing a letter off of the prefix until this uh evaluates to false.
So I guess would you just put another conditional after this while loop saying if it was false, then you would return an empty string?
Um,
Well, actually, you
oh,
wouldn't
that's a
have
good point.
to,
Yeah, that's a good point. So what happens if
like with the dog portion.
right. So if we do that here, yeah, let's see. So if we put in that test case,
Well, it is empty.
hmm, yeah, I guess that works. But why? Oh, because the prefix eventually becomes empty because there's
You're taking off one for each.
yeah. So let's do this.
Yeah.
So it initially puts dog in there,
Yep.
and then since there's no common prefix there, um, it'll just
Start
base
taking off one by one.
yeah. And so and so for the next one, there's nothing in prefix, and so that works there. But let's see. What about this case? Aha, we do have an issue there.
Well, you could just check prematurely saying if the length is less than two, you can just return an empty string.
Sure. Exactly. Let's see. Let's go.
Well, I guess I have a question. So in the problem initially, it didn't say anything about an empty or like a one portion. Um, well, I guess yeah, you could assume it'd be empty since it needs to be a common prefix. So yeah, sorry about that. Yeah, you're right.
Yeah, so it has to have a common prefix there.
So I guess I don't mean to like code on your solution, but I guess would you put like if length of strings is less than two, then return that. Is that what you'd have in mind?
Yep, yep. Because yeah, because if you only have one, and let's just say yeah, that would also account
So I
for
guess like if we did do this, then it would just be an empty. Okay.
yep, yep, exactly.
Yeah, this is definitely a much more simpler approach than what I was thinking of.
Do you want to see if you can finish your solution? You just keep,
Um,
or you kind of beat to death on this one?
well, it's not like I was remotely far off. I was pretty close. I did get the first part, but I guess it got a little tricky when I was doing validation, which, understandably so, because we started to see what I was putting into the set and how I guess I was going out with the set incorrectly.
Yeah, you had an interesting approach. I'm not you it you could definitely come up with the right solution that way, but I think it just there was a few minor changes that you needed to make
Right.
where you were checking character by character.
Definitely.
The difference is here is that I'm doing a substring comparison, um, and then basically slicing the
Yeah. Yeah, you're just slicing one off each time, one
yeah.
character off each time.
Mhm. And using like built-in functions like this is completely fine. You
Right.
can you can use like the find. You can even I think there's like a slicing there's a slice method too that we could have also used, but all this is completely fine. Of course, they're gonna want you to be able to defend the type of big O that you used, right?
hmm
So if you look at this, what is the big O?
Well, I guess to understand is find order n, to find the substring. Would that also be an order n operation?
Yeah, it's linear, it's order n in context of the amount of letters that it has to check between the prefix and the
Right.
string.
So I mean you have one loop to look per the um look at the each string and then um initialization that prefix is constant. You have another while loop which checks with another order n algorithm, and then slicing is constant. So this is definitely would this potentially be order n log n?
Why do you
Because
think the end
well,
login?
because there are two for loops, and then you did say that so is I guess the string find, this would make this a logarithmic function.
Find find I don't believe is logarithmic. I mean,
Well, not fine, but this whole algorithm, this whole function, like this double loop and also an order n.
so what can we determine about this loop here? Do
We're just going through each
is
string,
it
so that's order n.
okay?
And then the other one is going through each character in a string. Actually, no, so you're doing another while loop to say while that is equal to 0.
So what is
So
it?
this would just be another order n
Mhm.
loop. So this is just log n.
Well, uh, let's see. So while strings of I and